Welcome back, and in this session we are going to be looking at the most important molecule for life as far as we know, which is water. Water is an extremely unique molecule. Most small simple molecules like water, if you think of similar ones, carbon dioxide is a gas, oxygen is a gas, nitrogen is a gas, methane is a gas. Very similar molecules tend to be a gas because they're smaller and they have less intermolecular forces. So we're going to learn how the physical and chemical properties of water make it so unique to life. And there's a good chance that a lot of your exam questions are going to be based upon water. So let's dive in. The spec point that we're going to be looking at is this one here, which comes under the biological molecules topic. Now, what's quite common to this topic is you have to physically learn the content, but there's a lot of examples of application. So we're going to do some exam questions at the end of this. So we're going to learn how we would apply this in a real exam situation. A reminder, you can get all of these resources simplified for you. You can just download them as a PDF. You go to biobud.uk and log in. It's completely free. Download them for the workbooks. They're completely free. Organised practice mini section questions for the entire specification. Every chapter is completed. So whether you're Year 12 or Year 13, there's one for you. They're designed explicitly for OCR A, but if you're a different exam board, they will be really helpful too. So let's start on water. Now, water, we don't have to actually explain why, but I'm going to help you understand why water is so unique. You're not going to be asked for this level of understanding. I'll tell you when you do need to know. So the first thing is, if we take an oxygen molecule and then we put alongside it a hydrogen molecule, the oxygen molecule is much larger. If you look where it is in the periodic table, it's got a much bigger mass. As a result of that, the covalent bond that's shared between oxygen and hydrogen, the electrons are on average nearer to the oxygen molecule. That makes the oxygen, because electrons are negative, slightly negative. Not a whole charge, but we call it delta negative. And the hydrogen becomes delta positive. And as a result of that covalent bond, we end up with something called a dipole. We have two poles within the molecule. We have a negative region and a positive region, and that's the same for the other hydrogen. Because of that, water now has the capacity to build stronger and more intermolecular forces. This is why water has so many properties. What we can now form is a hydrogen bond between different water molecules. This is the most common bond you can look at in biological molecules, which is the hydrogen bond, normally between hydrogens. It's a very weak intermolecular force because of these dipole interactions. That's what makes water sticky to itself. And often we refer to that as adhesion and cohesion. Cohesion is when it sticks to itself. Adhesion then is that might then go and stick to the inside of a plant xylem, we would call that adhesion. Now, because of this force, there's all these unusual characteristics, and what you will have to do is apply these in the exam to real life situations. So for instance, it has this unusually high boiling point for such a small molecule. That means therefore, and this is your first bit of exam technique, is whenever you make a statement, imagine the word therefore is in the middle and then finish the sentence, and that will often gain you extra marks in the exam. Most of the time they want the reason why rather than the pure recall. So it has an unusually high boiling point, therefore it's going to be liquid at room temperature. It has a high latent heat of vaporization, which means a large amount of energy is required to change state from the liquid up to a gas. Now that can be applied in lots of ways, and that's very useful to things like sweating. So when we sweat, we move salts and ions onto our skin. That causes osmosis. Water goes to the surface of our skin. As a result of that, a lot of energy is taken from our body and our bloodstream mostly to then cause that water molecule to then go into a gas. That does a lot of cooling on the human body, and that's why endotherms in Year 13 are able to survive even when the environment temperature doesn't match their body temperature. Now, because of this unique property of these hydrogen bonds, it does a weird thing where the molecules spread out. So it's less dense as a solid. So as a liquid, whatever the distance is as the molecules are, when it becomes a solid, there's less energy to break those hydrogen bonds. They become stronger, and as a result of that, the molecules themselves move further apart. So therefore now it actually becomes less dense, so it floats. Now again, the application of that, the value of that, is that then creates a habitat. Also, if you're a fish living, or some kind of aquatic organism living under the water, you've now got an insulating layer from maybe a very cold temperature on the outside, a really negative temperature. You've now got an insulating layer between you and your liquid water where you survive. Now, cohesion is when it attracts to other water molecules. Now, we take advantage of this, and some examples in A-level biology is when we look at thin layer chromatography or even paper chromatography. A solvent Now, we're explicitly talking about water, so let's go with paper chromatography. The water molecules stick to the stationary phase, the paper, because of these adhesive and cohesive forces. So it sticks to the paper in adhesion. It forms bonds with the molecules in the paper, but also it forms bonds with itself. So as some of the water is pulled up, capillary action occurs where the water just below it is then pulled up, and that repeats. That slowly moves it up the stationary phase, which is pretty helpful for chromatography. This can also be applied to transpiration. This can be applied to the xylem in general water moving up the xylem. And on top of that, it can have really strong cohesive surface tension. That's going to allow various insects to live on water. Naturally, insects, in their lives, they have to worry more about surface tension than gravity. Now, in action, this is an old recording from a lesson of mine, you can see the water droplets just touch, and you can see it staying together. That is the cohesion. And you can even see just there. You can see now it attracted to the table and that pulled the water. So you have the adhesion and the cohesion taking place at the same time. I've got a fill sheet here. If you want to go and practice about this question, feel free to use this. Now there are some more examples of the application I want to talk through with you. So the big one is, it's the universal solvent. Because it can form bonds, things dissolve in it. That allows biological molecules to do two things. They can be transported, think of the bloodstream, xylem and phloem, or it could be a medium for chemical reactions. Without it, there wouldn't be any movement within a cell. On top of that, not only does it have a high latent heat of vaporization, it has a high specific heat capacity. So we can summarize that it has a stable temperature, which is really good in particular for ectotherms. Ectotherms are things like insects and fish, things that can't regulate their own body temperature. They rely on the surroundings to regulate it. So if you're living in water, it provides a stable environment where your body temperature is not going to be exposed and change very often that could cause you to die. Now, this is a classic style question that you're going to get, where you just have to quite simply draw two water molecules and label the bond between them. So feel free to pause and have a quick go. And you don't, as I said before, you don't have to be able to draw the dipoles and describe it in that much detail. This is good enough. However, you're now going to have to draw a hydrogen bond, because it says and label the bond, a hydrogen bond between the two water molecules. Now we've got an explain question. When you get explain questions, you want to say why and how things happen. Give as much detail as you can. Often mark schemes will say something, comma, something, comma, something. So don't hold back. Don't stop here or here. Try and give as much detail as you can for every marking point. And a general guidance is you want to be saying one or two things for each marking point. Very, very unlikely you're going to say three things to get 3 marks here. So say everything you know on this topic area. It's worth investing the extra time. So for instance, we might say one of the properties is cohesion. So explain not how we form the properties, how the properties of water is related to transport. Now, a lot of questions here, a lot of questions on water will pick one particular property out that you have to apply it to. So one property, so you've got cohesion, adhesion, solvent, etc. So cohesion, well, let's explain what that means water sticks to itself. So I'm going to give them an explanation. Also going to include an example, such as, now it's in a stem of a plant, so such as in the xylem, and I'm now going to apply it to transport, which is going to allow a chain of water to move up the xylem. And I would keep going here. I would then say this is in the process of transpiration. I would then give more details. This may also carry ions. So I think so far I'm probably only on 1 mark. So it's a lot more at A level. So to get another mark, I'm going to mention another property. Well, cohesion, another one, is quite simply. Adhesion is the process of water molecules sticking to other things, such as the inside of the walls in the xylem or of the phloem. And that's going to allow it to move up by capillary action. And now I'm going to add a third property, and I'm now going to mention that it's the universal solvent. I'm now going to explain what that means. That means other molecules are able to dissolve them by forming bonds. Now I'm going to explain it in transport in the stem. I'm not going to say so things can move around. I'm going to say such as sucrose, which is going to move during translocation, which is going to move up and down the phloem. And you can check your answer here now with the official marks. Now again, this is another example of a big 6 marker where you need to apply your knowledge to the wording of the question. So we said outline. Now stop and think, what does outline mean? Outline means an overall summary. What they want from outline is a little bit about everything. They don't want you to go into incredible detail about one thing only. You can go into lots of detail about lots of things, but don't just do lots of detail on one thing. We want an overall summary. So it's like if I was saying how to drive a car, I wouldn't spend 10 minutes talking about how the ignition works and how that starts the engines and causes all that. We don't need to. You put it in the ignition, you turn it on. And you go through all the different steps rather than lots of information on one step. So we're going to go through the properties again. So we'll go through and we're applying them to sustaining life. Now they tell us in the question we're not allowed to talk about temperature. So you can be tempted to mention it, but it won't get you any marks. They've taken that away because they've said other properties. And a lot of students will miss that. So we go ahead and we start listing the properties. Now feel free to pause and have a quick go and then see what you get. So for some of the properties, we might say it forms hydrogen bonds. It has dipoles. We might say it can act as a solvent, as a temperature buffer. It's less dense when it's solid form. It's liquid at room temperature. Adhesion, cohesion, capillary action. Yeah, so you start listing those out and feel free to bullet point those as a list and then apply them to each reason. It can't be random. So for instance, if you said it's very temperature stable, it has a high specific heat capacity property, therefore sustaining life, therefore it provides a stable environment for things like aquatic organisms. It has adhesion and cohesion, therefore it allows water to stick to itself and the inside of a xylem that then pulls it up during transpiration. It's a solvent, therefore ions and minerals in the xylem are allowed to dissolve in them and move up the plant. So for every property you need to apply it to sustaining life. Now it's really important here that you give an example each time. The way that leveling works at A level, it's not write 6 things and get 6 marks. What you have to do is follow the guidance from the question. And the question says you need a chemical and a physical property. Now, there wasn't anything in the question that really told you had to separate them. You don't have to separate them. They just wanted an outline, an overall summary. So to give an overall summary, you're going to give some chemical and some physical. If you gave 4 chemical and 1 physical, that would be fine. But for each one, you need to apply it to the example. So for instance, if you said it's a polar molecule, therefore it's a habitat, that's no good. You need to say it's a polar molecule, therefore things can dissolve in it. It can form bonds. It can act as a universal solvent. And if you want to have another go at another question, here's another one. When you're checking the mark scheme and you see a slash, you can say one of the 2 things. But when you see a comma, you need everything either side of the comma. So you have to say ice is less dense than water or ice floats on water. One of those 2 things is needed. For instance, here in marking point 2, ice provides a habitat for some species, or you might say in alternative wording, ice allows a place for species to hunt. Something along those lines. Okay, great work. And in the next lesson, we're going to now start to look at carbohydrates.